I didn't. I was making sure. I'm always paranoid now that I printed them off since the one day I forgot. They're really, I should have printed them off.
It's not never too late.
Yeah, I'm already, but I'm kind of mad at Grady, so now you don't give a print off. Today we're going to talk what does this say tomorrow? We'll talk about population models. I feel like we're talking about population models today. I feel like this is an untrue statement. That's right, here we go. You got to write this down. Sorry. If you write stuff down. I lost my blue marker and all this ridiculousness. I bet 80 of them are doing stuff.
We're finishing up our simulation.
But that's something. That's not Halloween related. That's the point.
We're dressing up as congressmen and congressmen.
I'm the Speaker of the House.
See?
Yeah, but it's fun.
Nothing we ever do in here is fun. So you just need to accept it. It's because I'm recording. It always does that.
Yeah, bye, Dave.
I just canceled.
I just canceled. Whoa. We're skipping over the 14th. 13th.
We kind of wrote this out before. Today we're going to talk more about writing equations for growth and decay, talking about the growth factor or the decay factor. But notice it's still that same. I think that's a move, right? It's kind of in the wing. That's a little flashing arrow. Let's move it up there. When I record, it does. It always does. It's like it's because it's Halloween. That's why it's flashing.
So you are doing something Halloween related. I'm not mad after all.
Notice that if A is bigger than 0 and B is greater than 1, then we will say if you plug in bigger values for x, it's going to keep getting bigger. That's what makes it an exponential growth model. That means when we graph it, it looks like this, right? As x gets bigger, y gets bigger. When they ask you for the growth factor, it's just whatever the base is, right? That's just a fancy word. So if A is still bigger than 0, and now we pick a number less than 1, then if you pick like a fraction, like 1/2 or 1/3, then that means as you take bigger powers, it's going to get smaller, so it's going to be decreasing, and it's going to be an exponential decay function. And so that means it's going to look like this, right? It's going to be flipped over. There are lots of extra things that can happen, like what if they throw a negative in the exponent? What if A is not greater than 0? Right? Like you have to really think about it sometimes. Or you can just plug numbers in and see, is it getting bigger or is it getting smaller? Part of your homework today, you just have to say, is it growth or decay? And what is the growth or decay factor? But sometimes it's a little tricky, so let's look at a couple of those.
We have to use spectators soon.
We might. Yeah, there's a lot of algebraic ways to solve these equations, but we haven't learned about them yet. So today we're going to kind of just look at the graph to solve equations. Maybe.
I'm sorry, I can't even be. Stop like it works. I know that, no way.
State whether the function is exponential growth or exponential decay. And again, I try to give you ones that are kind of tricky that aren't straightforward because that's what the book says. If you're not sure, an easy way to do this would be to plug in values plug in values for x and see what's happening. Is it getting bigger or is it getting smaller? This one, the exponent is negative, right? So we could do a couple things to try to make it fit what we did before. If we wanted to get rid of that negative exponent, could I write that, like move that to the bottom so that becomes 1 over 3 to the positive 2x? So you agree with that statement? Negative exponent can move down. If you get rid of the negative exponent, it kind of fits with what we just wrote, because what we just wrote, x was always a positive exponent. And so now, do you agree that this is a fraction 1/3, like less than 1? So if I keep plugging in bigger and bigger values for x, do you agree the denominator is going to get bigger, but since it's a fraction, like that y value is going to keep getting smaller? I tend to think about if the exponent is negative, then I know that that's going to be flipped over because I think about transformation. So you might not need to do this, but I'm going to say that this is exponential decay because as x gets bigger, the y values are getting smaller. Question? Anybody have a guess? Because why? Yeah, this is going to keep getting smaller too. If you wanted to kind of make it look like this, you could bring that up and make it e to the negative x, right? So again, it kind of matches how that one was. But you've just had to think about what is the base. 1 over e is a fraction less than 1, so that's why it is also exponential decay. So just be aware that you have to look at the base and you have to look at the exponent, whether it's positive or negative, to kind of see what's happening there. Questions about that? You don't have to graph those, that's nice. If you did your other homework, you have graphing stuff. Oh my gosh, who would give me such a terrible problem? But that's someone telling me I should only be doing Halloween stuff today. Hello? Okay, thanks. Lydia, you're supposed to go to the office.
Don't run though. I don't know.
Yeah.
You know that.
I don't know.
Wait, so what was the thing you said? Why would someone Halloween or whatever?
Someone's going to call me and tell me I'm not supposed to be teaching today. I'm supposed to be having a Halloween party. That's what I thought it was.
It's elementary school.
This is high school.
Junior high.
No, I don't believe in Halloween.
Okay, let's get like.
No, we're going trick-or-treating and we're going to freeze to death, probably.
You say you are going to?
Yeah, we're being Phineas and Ferb.
The whole family is?
Yeah, Parker's Phineas, and I'm Ferb because Ferb is taller than Phineas. And Nolan is Perry the Platypus. And my husband is Dr. Dubenschmertz.
No, it's
No one's Candace.
Why didn't you be like Candace or something?
Because you can't Phineas without Ferb.
Oh, you might have a dog.
Yeah. Well, what was my husband going to be? He could have, like, we just made him Dr. Dubenschmertz.
I want to see, you should take a picture.
I'll try.
Okay, I want to see the platypus.
Yeah, you the voice.
No.
Wait, are you guys making homemade costumes? Or
We are making homemade costumes.
Very big.
Yeah. Good thing they're already made since it's tonight, right? What? I am. I have. Hopefully it comes out. I said good thing it's Friday. I have a few days to keep watching it.
Great.
Otherwise, I'll become this old green halo.
That'll be so great.
But Ferb's really easy. He just has purple pants, but he hikes them up really tall. So I went and bought some kind of extra big pants that I can hike up really tall. And a white polo shirt. I just bought scrub pants, like at Goodwill.
Look at you.
Yeah. And then a white polo shirt. That's easy. Spray my hair green. Done.
I
That's.
think my last time going trick-or-treating on the mountain, I was like,
And Nolan, Perry the Platypus, we were going to try to make an outfit, but instead I just bought an oversized Perry the Platypus shirt that has his face on it. And I'm just going to like safety pin it and make a whole little jumper out of it. Only it's going to be 30 degrees, so apparently I'm going to put some pants on underneath that. But, and I have little tail for him and feet. And a hat. He's probably not going to wear it, but
I'm gonna try.
we're going to try. We're at least going to get pictures. I'm trying to convince Parker to just go to like around the block and then come back to the house and hand out candies in the nice warm house. But so I'll just buy him more candy.
Even just like everybody slowly just like dump a little bit of your candy into his bag, so it looks like every time by the end you're like, look at all this.
I know, let's go home.
So warm.
Wow, we live in the 3 houses.
But look how much candy you have.
This is a logistic function. When we talked about the functions that we should know, logistic function was one of them. But it's also, you can see there's exponential function in there. But they tell us that the population in Ohio can be modeled by this function, where P is the population in millions and T is the number of years since 1900. So part A says, how many people were there in 1950? What does that mean you need to do?
Have 50 years.
Yeah, plug in 50, right? That's telling you it's 50 years since 1900, so the time is 50. You just have to plug 50 into this equation and be able to do it correctly on your calculator. You have a couple options. One option is you can type it in all at once, make sure you put parentheses in the bottom like this. The other option is do the bottom and then take 12.79 divided by that. I think you should practice doing this because, again, part of this chapter, you have to be able to use a calculator, so I'll throw you a calculator again. Who wants me to throw a calculator at?
Yeah. I'll catch you.
You already have one.
He's got, can you catch one?
Oh my God.
Whoa. Yeah, what's doing chocolate is doing calculator. We have bad names. Dylan stole Jacob's chocolate, so no.
Also, make sure if you're typing this in, when I hit E on my calculator, it automatically gives me the power with a parenthesis, but if it doesn't, you have to make sure you tell it to multiply all of this in the exponent, right? So don't close the parenthesis until after the 50. So 0.0309 times 50. What'd you get?
I got, I already
I got
added
13.3.
8.17. Anybody?
I got not your answer, so I gotta try again.
8. That's not bad. 6. But I still have
Negative 0.0309. I got 10.16. Nobody got 10.
I got 0.2133331.
Let's try again. And that includes the 12 up here?
No.
You have to include the 12.
I'm still not gonna get that.
Divided by, I did parenthesis 1 plus 2 point. Oh, I think I just made up a number here. I don't think I did just 1.02. Times E to the parenthesis negative 0.0309 times 50. All right, I'm gonna try again.
We should close parentheses.
Close parenthesis.
Yeah, I did get it. I think at the end I had 3 friends.
Did you?
I got 13.
There's 13 people in Ohio.
No, in P is the population in millions. So what you can say E to the negative 0.0309 times 50.
I still stick.
8.456?
Yeah.
Hey, just slow down. I'm still trying to figure out how to put my calculator. No, I don't have it.
Okay, you can have the 0.456 first.
Oh, I know, but it tells us that the population is in millions. So this is really like 8, that's why I include all these numbers here. 8,456,896 people. Or you could say like 8.5.
I gotta figure out what I did wrong with my calculator.
Yeah, so let me know if you didn't get that so we can look at your calculator.
4.79 divided by that. So you had 13.
What I did.
8.456.
8.456.
09
Anybody need calculator assistance?
times 50 parentheses.
Yeah.
I got it. I didn't put 2 parentheses. 3.
Except for I got 757 instead of 896.
Well, because you divide by 12.7 at the end, is that true?
It's 12.79 divided by
If you did it all at once, or you did it like you did the bottom and then you divided?
I did the bottom and I added one. Well, I did the 2.402. I added.
So that's why the end gets different, because I did it all at once, so it did it all at once. You rounded But it's getting smaller, so.
No, no way.
We don't know. It's not gonna be.
Well, first of all,
Never. We could.
let's think about for a minute. How much was the population at 1900? If we plugged 0 in for this, right?
Yeah.
If we plugged 0 in for this, this will be either 0 with just 1. I don't know, we can figure it out.
6.4 million. I swear, if you just like go to the right.
I thought you had a plastic glove on your hand for a minute, and I was very confused. I was like, why does he have a plastic glove on? If I wanted to know when the population would be 10 million, do you agree that I could kind of say, when would this equal 10 million?
Actually, there was 999,999 and 2 days before at the same time, so.
Oh, yeah, we could try some different values here. Do you think it's going to be more than 50 years or less than 50 years? I guess I should say T and P of T. We know that at 50 years it was like 8.5 million. Maddie says she plugged in 70.
I think you just plug it in 10 million.
I know, but we haven't talked about how to solve things.
You take the L in. You take the L in.
I'm gonna just, what's super great about your calculator, I don't know if you know this super trick, but if you just hit the arrow up, it has what you just typed in, and you can just go over and change that 50 to a 70, and you don't have to like type it in every time. And if
less 1 equals.
70 is a little over 10 million, so maybe we should check 1 year below that and see if it was 10 million yet. So let's check 69.
It's 9.95.
So I think it's
So
69.5.
we'll just go to the nearest whole number. So we'll say, when was the population 10 million? We'll say 1970. There is an algebraic way to do this, and by the end of this chapter, we will do the algebraic way where we can solve this equation exactly, but this is a decent way to do it now, right? Especially when you learn that trick that you don't have to retype it in every time. So one use of functions like this is to predict population growth. Remember I don't know what grade you guys were in, when the population in the world reached whatever, remember that? Billion, was it a billion? Well, Mrs. Hodge was very excited that also. And so like there was a little website that was like counting people being born, and that's just an equation, right? Like they don't really, no one like calls into an office and be like, we had another birth, you know, like no one does that. It's just like using an equation to predict population growth.
I think this is.
No one goes and reports it every time.
Giant call center in DC.
That reports. Oh my gosh, that's your whole notes today. Happy Halloween.
Yeah.
Do you have candy or something?
I got nothing.
Did you bring a lunch? We could split that up.
I have an apple. The teachers have pitch-in lunch today, actually.
16.
So,
I got an apple.
no, I brought some for that. But it's
When you bring the pitch in?
I brought 7 layer bars, which are delicious. They're delicious.
I am actually under suspicion of food poisoning, so I have to check those out. Make sure.
And I brought Mexican bean salad, which you should have at your fiesta today because it's delicious.
Wait, what? What salad?
Mexican bean salad.
I don't like beans. Or
Pretty yummy.
salad.
I'm glad we didn't say that. What you're about to say.
I love Mexican food, but I like.
Mexican's my fave.
I thought you were going to say something inappropriate.
No, I wouldn't have said that. I don't know why. What did you say?
Seemed like you all.
No, I said I don't like beans, and then I started to